Okay, so let's do in class 1, and number 1, it says find the angle between the vectors. So we're given the vector -3, -2, 11, and the vector u, -2, -5, 7. Okay, so we're going to use the theorem 2. So let me write it up here. The cosine of theta equals u dot v over magnitude of u, magnitude of v. Okay, so there's our formula here. So let's look at u dot v now. So let me do that. So we get this then, so u dot v, so it'll be -3 times -2, which I have here, -2 times -5, which I have here, 11 times 7, which I have here. You can check that's 93. Let's do the magnitude of u next. Right, so the magnitude of u would be the square root of the first component squared, second component squared, third component squared. So it's going to be 4 plus 25 plus 49, which is 78. So it'll be square root of 78 for magnitude of u. Let's do magnitude of v next. So the magnitude of v, here's my v vector here, it's going to be the square root of -3 squared, -2 squared, plus 11 squared. So it's going to be 9 plus 4 plus 121, so it's going to be then square root of 134. Okay, let's replace those over here now. So replacing, we get 93 on top, then square root of 134, square root of 178 in the bottom. Now let's take inverse cosine on both sides to find theta. So let me do it here. So taking inverse cosine on both sides here, inverse cosine and cosine would cancel, as be theta, and then inverse cosine on this side. Then plugging this into your calculator. I have my calculator in degree mode, so it's going to give you the answer in degrees. So plugging in the calculator, we get then roughly equal to 24.54 degrees. Okay, so we're done with the question. All right, let's go on to question 2 now. Okay, so here's question 2. So find the volume of the parallelepiped determined by the given vectors. So given our u vector, -3, -2, 11, our v vector, -2, -5, 7, and our w vector equal to 1, 1, 0. Okay, so we're going to use the result from theorem 5 now, so let me write it up here. Okay, so here's the result from theorem 5. This is the volume of the parallelepiped will be u dotted with v cross w, absolute value of this. So let's now find the cross product of v and w. Let me write it here. Okay, so I've written my cross product here. I have my I, j, and k on top, then my v vector, -2, -5, 7, second row, and my w vector, 1, 1, 0 down here. So let's do the I component first. So we're going to cover this. So it's going to be -5 times 0 minus 7 times 1. Let me write that here. So we get this. So again, it's -5 times 0, and then 7 times 1 with the minus sign. Then we'll do the j component next. So the j one has a minus in front. Then it's going to be -2 times 0 minus 7 times 1. Let me write that here. Okay, so I've written it here, so it'll be -2 times 0, 7 times 1, minus 7 times 1. And lastly, we'll do the k component. That's going to be -2 times 1 minus -5 times 1. Let me write that here. So we get this, so again, -2 times 1 minus -5 times 1. So the first one looks like it's going to be -7i, second one looks like it's going to be plus 7j, and this one looks like -2 plus 5, so 3k. Let me write that here. So I've written it here. So that's going to go in place of this guy right here then. So now we're going to go u dotted with this now. So here's my v cross w, here's my u up here. Let me write my u actually right here. Okay, so I've written my u here now. So dotting needs to be -7 times -3, 7 times -2, 3 times 11. So let me write that here. So I get this. So again, -7 times -3, 7 times -2, 3 times 11. So working this out then, that's 21, that's -14, that's 33. So let me write the answer. So we then 21 minus 14 plus 33, which is 40. And by theorem 5 then, the absolute value of this number will be our volume, but the absolute value of 40 is 40. So this guy here is the volume. So we're done. Okay, so let's go on to question 3 in class 1. Okay, so let's do number 3. It says find the equation of the line passing through 1, 7, 0, negative 2, 5, 11. Then determine if the point negative 8, 1, 33 lies on the line. Okay, I'm going to call this first guy P0 and call this guy P1. Okay, I've labeled them. Now let me write the equation of the line through 2 points in 3 space. Okay, so here's the equation of the line. It's going to be P0 plus P1 minus P0 times T. Okay, so let's start plugging these in now. So my P0 is this, my P1 is this. Let's plug it in over here. So look at this then. So it's P0 plus P1 minus P0 times T. So then combining the x components, you have a 1 here. You have minus 2, minus 1, so minus 3t. So it's going to be 1 minus 3t. For the x component, it'll be 7. For the y plus 5 minus 7, so minus 2t. And for the z component, it'll be 0 plus 11t. So let me write that here. So I get this, again, it'll be 1 minus 3t from there, and it'll be 7, and 5 minus 7 minus 2t, and then 0 plus 11t. Let's write in the I, J, K notation below it here. Okay, so writing the I, J, K notations, this will be the I, this will be the J, this will be the K. Now we have to determine whether negative 8, 1, 33 lies on the line. So let's suppose it does and see if we can find a t value that makes this point. So let's suppose that r of t equals that. So we're supposing r of t equals our negative 8, 1, 33. Well, that would mean that the negative 8 would have to equal the 1 minus 3t, the 1 would have to equal 7 minus 2t, and the 33 would have to equal 11t. So you'd have 3 equations. Let me write them here. So you have these 3 equations, and let's solve these. So subtracting 1 here, and then subtracting 7 here on both sides, and dividing by 11 on this. So let's do that. So subtracting 1 on both sides here, subtracting 7 here, dividing 11 on both sides here. So here you get then negative 3t equals minus 9. Here you get minus 2t equals minus 6. And here solving this one you get t equals 3. So we're going to divide this guy by minus 3, divide this guy by minus 2. So dividing this guy by minus 3, you get t is 3. Dividing this by minus 2, you get t is 3. And this one's also t is 3. So t equals 3 satisfies all 3. So that means that r of 3 up here will be this point. So it means this is a point on the line. So hence, let's write our conclusion now. So hence we can say our negative 8, 1, 33 lies on the line since r of 3 is equal to minus 8, 1, 33. Okay, so we're done with this question. Now let's go on to question 4. Okay, so question 4, find the equation of the plane containing the points 1, 7, 0, negative 2, 5, 11, and negative 1, 2, 7. Okay, I'm going to let this first one be P0, call this one P1, and call this P2. Okay, so label them. Now let's find our V1 and V2. So V1 is defined to be P1 minus P0, and V2 is defined to be P2 minus P0. Let me write that here. Let's first look at V1. So it's P1 minus P0. This is my P1, this is my P0. So let me write them here. So I get then negative 2, 5, 11, minus 1, 7, 0. So it'll be minus 2, minus 1, so minus 3, 5, minus 7, minus 2, 11, minus 0, 11. Let's do V2 next. V2 is defined to be P2 minus P0. Okay, so then my P2 is negative 1, 2, 7. Then subtract my P0, 1, 7, 0. Negative 1, minus 1, so minus 2. 2 minus 7, minus 5. 7 minus 0, 7. Okay, now we have to do the cross product of V1 and V2. Let me write that here. Okay, so here's my V1 cross V2. So I got my I, J, K, then my V1 vector, which is negative 3, negative 2, 11. Then my V2 vector, negative 2, negative 5, 7. So let's do the I component first. So I cover the I column. So it'd be negative 2 times 7 minus 11 times negative 5. Let me write that here. So we get this then. So negative 2 times 7 minus 11 times negative 5. Then we'll do the J one next. So the J will have a minus sign in front. It's going to be negative 3 times 7 minus 11 times minus 2. Let me write that here. So again, we got negative 3 times 7 minus 11 times minus 2 here. Down now we'll do the K component. So it'll be then negative 3 times negative 5 minus minus 2 times minus 2. Let me write that here. So we get then negative 3 times 5, which I have here, then minus negative 2 times minus 2, which I have here. Okay, now let's simplify these things here. So simplifying, we get 41i, because it'll be negative 14 plus 55, 41. And then it'll be, this you can work out, it'll be just negative 1, so it'll be negative j, and this you can work out, it'll be 11, so 11k. Okay, now let's write the equation of the plane. So here's the equation of a plane. It's going to be V1 cross V2 dotted with P minus P0, where P is the X, Y, Z. So let me write that out here, what we have in our case. So I get this. So I'm writing my V1 cross V2 as just V1 comma negative 1, 11, and dotting with my P minus P0. P0 is up here, so it's going to be X minus 1. Then y minus 7, and z minus 0, and this has to equal 0, so let's dot these. So it'll be 41 times this, negative 1 times this, 11 times this. Let me write it here. So we end up with this then, so it'll be 41 times x minus 1, negative 1 times y minus 7, 11 times z. And let's multiply this 41 in here, and multiply this minus in. So let's simplify that. So we get this then, and let's just combine the negative 41 and the 7 to give us a negative 34. So I'm going to write it here, my last step. So last step will have then 41x minus y plus 11z minus 34 equals 0. So this will be the equation of the plane determined by original 3 points up here. Now, if you wanted to, you could check to make sure that each of these 3 points is on this plane here. I'm not going to check that here, but if you wanted to make sure you got it right, you could do that. So you put 1 in place of x here, 7 in place of y. It should end up being 0. I guess if I check that one, it'll be 41 minus 7, so which is 34 minus 34, 0. So that the P0 point works. You can check the other one, the other two if you wanted to also. But we're done. This is our answer right here. Okay, so we're done with in class 1, so I'm going to stop the video now.